Hello, and a very warm welcome on behalf of NTI Audio. Today, we are presenting to you solutions for testing Bluetooth audio devices. First, let me please introduce myself. My name is Markus Becker. I am moderating this presentation, and I'm assisted by Greg Schmiele. He is responding to your questions, and he will assist me if ever necessary. The topics that we have prepared for you start with an overview on the Bluetooth standard and the backgrounds of that standard. We will then take a closer look at the so-called profiles. I will explain what that means and the related codecs. We will have a closer look at the Bluetooth interface box and the pairing process. I will then introduce to you a typical test setup and measurements before we enter the practical presentation. After that, I will summarize the hardware and software modules that are needed for executing a Bluetooth audio device test. I will summarize the key points of this webinar and add some more hints and tips. At the very end, I will take a look at the questions that have popped in and possibly add some more comments. I expect that this webinar will last about half an hour. Well, the Bluetooth standard was developed and launched in the 1990s, and the purpose of the standard was to simplify the data exchange between electronic devices. It was a time when the first mobile phones or the mass market of mobile phones opened up. So there was a demand for connecting these devices to PCs or maybe to wireless headsets. And for that purpose, the Bluetooth standard was developed. The name of the standard comes from this gentleman, Mr. Harald Bluetooth. He was a king, a Danish king, and he was renowned for having unified several Danish tribes into one kingdom. So that was the idea behind the naming. Maybe you wondered where this Bluetooth logo comes from. Just a short side note. This comes from these two runes, which represent the initials of Harald Bluetooth. The Bluetooth standard has evolved since its launch. Currently, we are having the version 5.0, which offers an improved security and an improved reach versus the previous version. It has introduced a low energy mode and more individual profiles for different applications. As stated before, I will come back to this term in a minute. There is already a new version coming up for the Bluetooth standard, the 5.2, which will mainly comprise a low energy audio streaming between multiple devices. And I guess you can already see that especially audio data transmission, audio streaming plays a very important role in the Bluetooth standard. I would guess that a big portion of Bluetooth applications is related to audio streaming. So let us dig a little bit deeper into these profiles. The Bluetooth standard offers some dozens of profiles. A profile is a type of communication, or if you want, a communication protocol. And these profiles cover different applications. 3 of them are especially targeted on audio data transmission. And that is the A2DP, the Advanced Audio Distribution Profile, which is a unidirectional data transmission, for instance, from a TV set to a loudspeaker. Here we typically have the demand for a high audio quality, and what that means I will show you just in a second. Then there are 2 more audio-related profiles, the HSP, headset profile, for instance, for the communication between a smartphone and a headset, mainly voice transmission, or the HFP, the hands-free profile, which is targeted, for instance, for connecting a car entertainment system with a smartphone. Here we do not only have voice or music transmission, but also additional data like your address book or other related data. Well, when we look closer at these profiles, we can see here some specific specifications for the A2DP. Remember, it's a unidirectional data transmission from a source to a sink. We have 3 different codecs with different sampling rates, the SBC 44.1 to 48 kilohertz. With the AAC codec, you can go up to 96 kilohertz, and with the aptX, 48 kilohertz. The different sampling rates result, of course, in different data rates. The HSP, which is a typical headset profile, it's bidirectional, which means the communication is between the gateway and the client in both directions. Here we have the so-called SCO codec. Codec means the algorithm or the technology that compresses the analog audio data into a digital audio stream. Here we have a sampling rate of 8 kilohertz because it is mainly targeted on speech transmission, and the HFP, the hands-free profile, also being bidirectional between gateway and client, offers 2 codecs at 8 or 16 kilohertz. Please notice that the codecs that are marked with an asterisk are supported by the NTI Audio Bluetooth box by default. If you would need one of the other codecs, please contact us and we will look for a solution. But now let us take a closer look at this Bluetooth box. Here we see the front and the rear panel of this box. Mainly the purpose of this box is AD and DA conversion. So converting the analog signal into the digital Bluetooth data stream and vice versa. Furthermore, the Bluetooth box offers a trigger output. The trigger output informs you as soon as the pairing has been completed successfully. I will explain this to you just in a minute. The Bluetooth box supports all 3 audio-related profiles, ASDP, A2DP, HSP, and HFP. It supports these codecs, as stated before. It also supports the noise reduction and the echo cancellation, which are special features of the Bluetooth standard. And it has these electric interfaces, XLR connectors for the analog audio input and output. We have a digital I/O connector for the trigger signal. It's that one here. And we have a USB connector at the rear side for communication to the Bluetooth box and also for the power supply. Last but not least, each Bluetooth box comes along with a small software package. It's a graphical user interface by which you can control the Bluetooth box from your PC. You will see that in the practical presentation. Now, we have to take a closer look at this pairing process. Pairing stands for connecting 2 Bluetooth devices with each other. There is a standard procedure which you probably already have applied or used in your life, for instance, by connecting or pairing a smartphone with a wireless headset. So you start typically by switching the involved devices to the pairing mode. Then the smartphone, for instance, starts scanning for compatible devices. It offers you a list of Bluetooth devices it has found within its reach. And then typically you would manually select the desired device. However, it is also possible to automate this procedure, so to apply a certain condition or algorithm so that the source or the gateway in this Bluetooth application will automatically connect to the sink or the client. There is also an alternative pairing procedure available, and that is by directly entering the MAC address of your Bluetooth device into the source or the gateway. You could also read, for instance, this MAC address, for instance, from a barcode, which is a very nice feature, especially in an automated production line. Please note that the pairing process always includes the activation of a specific profile. This is typically done automatically. That's the default procedure. But you may also select this profile manually or by your intention. So, for instance, if you want to test a specific profile of your Bluetooth device, you can do so by activating it via for instance, the software we are offering. Last but not least, as soon as the pairing process is completed, as stated before, the Bluetooth box will generate a trigger signal as a feedback to your system so that the audio test procedure can start. These three features, the direct pairing with a MAC address, the controlled profile selection, and the trigger signal, are the most important features or very important features in an automated production line. Now, let me show you two typical test setups. This one would be schematically the signal path of a Bluetooth device speaker test. Here we have our Bluetooth device. So we generate the test signal. We transmit it via the Bluetooth box. Here we have the analog digital conversion to our device under test. We pick up the generated sound with a microphone, feed it back to our audio analyzer, and calculate the results. If you want to test the microphone of the Bluetooth device, we have to somehow invert this signal path, which means we create an acoustic sound. The test signal is acoustically generated. The microphone in the Bluetooth device picks up that sound, transmits it to the Bluetooth box. Here we have the digital analog conversion when this feedback is connected to the analyzer. The typical measurements that are executed would be the level or the spectrum of a signal, the distortion, or the interchannel phase between the two channels of a stereo Bluetooth device. And the test signals we are using are typically a sine wave at a certain frequency, or a glide sweep, or pink noise signal. The selection depends on your requirements. Well, we are at the point of our practical presentation. So here you see the involved modules. We have an FX100 audio analyzer. We have a reference loudspeaker. Here we have our test jig, which we created by ourselves with two microphones and the two earbuds that we want to test. The earbuds are connected to the Bluetooth box via Bluetooth link. The microphones are connected electrically to the FX100. And then, of course, we have also connection between the inputs and outputs of our analyzer and the Bluetooth box. And the whole setup is controlled by PC. I can also show you that in this with this webcam as the reference speaker, we decided to take the TalkBox. The FX100 is generating the test signal and analyzing it. The Bluetooth box serves as transmission emitter, and here you see our test jig with the two microphones and the two earbuds on both ends. But now let me switch over to the PC software that controls the whole procedure. This is the FX Control software, which comes along with every FX100. And this software offers several features. For instance, also the definition of a sequence of a automated or half automated test sequence, which I will present to you right now. But let's first step through that sequence. And the first thing we have to do, we have to pair, we have to connect our Bluetooth box to the device under test. So this would be our graphical user interface. Here we select the profile we want to apply. Then we would click on the scan button. I already did that. The software has found these 3 devices. So this is the identification of our earbuds. I click on the connect button. So this takes, of course, a couple of seconds to in which the Bluetooth box connects to the earbuds. And as soon as this red LED lights, we have the connection established. So now we can start the test. I do that step by step. I start here with the test of the loudspeaker of our earbuds. We have the green spectrum, FFT spectrum of the right channel and the pink of the left channel. Here we have the level, the wideband level of the left and the right channel. We have the distortion of the left channel and the right one. And here the interchannel phase between the 2 stereo channels. Our test frequency was 997 Hertz, by the way. And here you see in the spectrum the upper harmonics of this test tone. Well, the next step would be a glide sweep for frequency response measurement. I run that test. So here you see the frequency response of the 2 speakers. Again, the green and the pink curve, they're pretty close to each other. We see the distortion response from the 2 channels and the interchannel phase between the 2 channels. Now, the next step would be an HFP spectrum analysis. And for that purpose, of course, I have to reconnect my device under test with the HFP profile. So I have to disconnect it first, select the correct profile, and connect again. So this takes again a couple of seconds. And as soon as this connection is established, I can continue my test. Here the red LED shows me I can continue. So let's get back here. I run single. So the HFP profile, as you remember, is a bidirectional but mono, so single channel profile, which means, of course, one channel only. So I can only test here the speaker first, and then in a second step, the microphone. Maybe you heard in the background the test tone from the TalkBox. So here, this is the spectrum of the loudspeaker of my earbud, and this is the microphone of the earbud and the corresponding distortion values. And the next step would be, as before, the frequency response measured with a glide sweep. Here we have it from the speaker, and last step would be the microphone. That's what you see here. Here we have the frequency response from the microphone and the distortion response. Well, maybe you notice that the bandwidth of the frequency response here of the HFP test is much more narrow than of the A2DP. I'm going to show you that. Here, see, we come almost to maybe 8 kilohertz with our frequency response. If I compare that to the previous test here, we went up almost to 20 kilohertz. And the reason, as I explained to you, is the higher sampling rate of the A2DP profile compared to the HFP. Well, what I showed you here was the manual step-by-step procedure, but I can also do that in one run, the whole sequence. I'm going to show you that right now. So I go back to start point, step 1. I start the process. Now the software reminds me that I have to switch the Bluetooth device into the A2DP mode. So I go back to my graphical user interface. I disconnect our device under test, select the correct standard, and connect. By the way, I could also automize this part, but what I'm doing here, if I enter, for instance, the name of my device under test in this line, because then when I scan for Bluetooth devices, the software would automatically connect to such a device as soon as it has found this name. So maybe I have to click again. Well, just a second. Yeah, connection is established. I can go back. I can click on OK. So now the single tone measurement will execute it. The glide sweep frequency response will execute it automatically. Now I get a reminder to pair the to activate the HFP profile. So I need to disconnect again my Bluetooth device and reconnect it now in the HFP profile. Established. Just one more side note. As soon as this red LED lights up, the trigger signal from the Bluetooth box would also be active. So I could use this trigger signal to automatically continue my test. What I'm doing here now manually could be automized. I just renounced on that in order to explain it in more quietness to you. So I confirm, and now the software will execute the speaker test, the microphone test, and the frequency response of the speaker and of the microphone automatically. In addition, I could also apply tolerance limits to have a passed-failed result, but I wanted just to introduce you to the basic principle of this procedure. Well, let me get back to my webinar presentation. And summarize the items that you need for a Bluetooth test. We need an audio analyzer. In our case, it was the FX100. We need the Bluetooth box for the data conversion and transmission. We need control software, the Bluetooth graphical user interface that I showed to you, and in addition, the FX control software, or here we have an alternative. Also, the RT speaker software supports Bluetooth testing. If you are uncertain about the right choice, please contact us. We will assist you in finding the right solution. Optionally, you could, of course, also customize your setup. You could write your own software. We have in our manual the whole set of commands, the communication, the communication interface, software interface to our device, just if you needed that. Then we need a reference, microphone, and loudspeaker, and a test jig. The test jig, by the way, has been established with a 3D printer here in our house, in our company. But of course, its dimensions or shape depend strongly on the device under test that you want to verify. Yeah, to summarize, the Bluetooth box converts Bluetooth into analog signals and vice versa. And the box can connect to any Bluetooth audio device, and it allows you to select the preferred profile. It also offers a trigger output that tells you as soon as the pairing process has been completed. Then, when you establish a test setup, we recommend to keep a distance of 0.5 to 3 meters between the device under test and the Bluetooth box, and possibly it is necessary to shield your test setup against an external source, against an external radiation, if that would result in any disturbances or communication problems. Furthermore, when we talk about the pairing procedure, it is recommended to minimize the number of active Bluetooth devices in the reach of the Bluetooth box. That speeds up the procedure if there are less or only one Bluetooth device. But you can also speed up the pairing process with two measures. The one would be to use this auto connect feature, so to enter the name of the Bluetooth device in this line, because then the software will automatically connect as soon as it detects a device with that name, or if you enter the MAC address into this line. And I can show you that very briefly. Here let you see back my graphical user interface. And now I have also here this text file. This is the MAC address of my Bluetooth device. So I copy that. If I can disconnect that. So here now I can enter that and connect directly to the Bluetooth device. So that means I don't have to scan for it. And that is maybe the fastest way to establish the connection. Well, I'm at the end of my presentation. Keep in mind, we will publish the recording of this webinar on our website. You see the link here. And furthermore, if you have any need for assistance or any open questions, please do not hesitate to contact us here in the headquarters or any of our subsidiaries or partners worldwide. We'll be very happy to support you. Me from my side, I want to thank you very much for your attention. I hope I was able to provide some useful information about Bluetooth testing. And of course, I would be very happy to welcome you again at one of our future webinars. You will receive an invitation as usual. Until then, have a good time. Very important. Please stay healthy and see you soon. Bye-bye.